I look into the conferences, the program, and the type of from the past edition, and the type of presentation. It is atypically technical for the kind of conferences I participated, but that was one of the reasons I wanted to have a change in that direction, to come here and learn stuff. It's I attended several conferences, and some were, I believe, difficult for me to understand, but nonetheless I captured a sense of what was being told. I also have more, let's say, selfish motivations, such as recruiting, finding new technologies for sure, people that I could contact, if not for hiring, eventually for searching other people, to look into communities, and also to see what will be the reception of my message and my approach here, which again, being such a technical event, and I trying to provide a message that connects the technical with the non-technical, I thought it would be interesting to see. And finally, Malaga is one of the reasons, for several, from different perspectives. One of those is because Malaga is becoming a very interesting point for technology. Small city, but growing, very dynamic. I wanted to see that directly, and I actually very happy and impressed. It does look like a fantastic place to be at least connected with in the future. I presented this idea of dynamic data visualization, which is basically a series of strategies for producing interactive visualization along with real-time data science, machine learning, artificial intelligence processes. In a way, it creates a stronger and more meaningful connection between human cognition and data, right? And it's very much based on feedback loops. So allowing the humans to quickly modify the angle or perspective over the data, to go deeper or to search in different directions, and create a flow of cognition. And that's basically what we try to do. In my presentation, I feature multiple projects in which we try to do that from different perspectives. I made the case also from different angles. One is simply the fact that data science processes didn't come out of the blue. They come out of our minds, right? And as it happens, many of the machine learning processes are things that occur naturally in humans, such as decision trees, k-neighbors. There are many algorithms that are very intuitive, and this intuition, this proximity with the process is very important. Another reason I put these two apparently different things together, like data science and every human, or minds in general, comes from the fact that data science grew being inspired by models of how humans think, classify, project, predict, etc. But then what is interesting also is that it's also there is a trend in the other direction as well, which is cognitive psychologists are looking into those successful models to also learn or produce interesting models or hypotheses about our brain. So all these are very entangled. Finally, I've been playing with my sons, and even doing some workshops in the school with other kids, teaching them and playing with them. More than teaching is really play and propose games that are basically typical machine learning algorithms disguised as a game. And I see directly how they are ready, prepared for that kind of processes. And very recently, I didn't comment this on the talk, and will be interesting. Very recently, there are a series of new books being published that go in that direction. One of these is I don't remember the name. I have it in my mobile, but it's a book for decision process for kids, more or less. It was a Japanese guy that wrote this book. He taught to very small kids, 5 years old, 6 years old, certain ways to solve problems. Problem solving 101 is the name of the book. It's fantastic. So it creates stories about kids that face some challenges, and they use typical MBA sort of analytical tools to solve problems and to find optimal solutions, etc. Beautiful, and among all the techniques, there you have decision trees, and you see all the possibilities, you weigh by probabilities or by how much easy is to get there, and then you find a combination of solutions is one of those examples. So I believe there is a trend, and more data science will also be part of education in a more evident way. Yeah. I think people, attendees, even if they come from a more technical medium, professional medium, all the concepts, even if the words are kind of atypical, etc., the associations were there, right? And I was always showing projects that work with data, so it's not super realistic. I mean, I think part of the challenge I face is how to make those connections evident. And there's another thing. I think there is a trend in the last years, and I've seen it happening in different countries, is that in general the programmers, developers, technical professionals are less or less just technical nerds. There is a sort of new diversity of interests. So they are nerds, but nerds in many different fields. If only if it's data, technology, and beer, I don't know. But you see like the spectrum of interests growing a lot. Also, the nerd became a sort of a cultural hero as well, right? In the last 20 years. They are no longer the individual that are lost in a cave with servers, etc. They are visible. The hacker is a sort of mythical figure and is a hero, and the developer solves problems, etc. You see them in action movies. So I think nowadays those connections are more natural, and I don't think, again, my words might be atypical, but they are not completely unconnected. I believe the connections are there, and we're gonna see more and more, I believe also, this kind of thing happening all the time. So cultural aspects being entangled with technical problematics. And finally, because science and technology, they are culture as well. So they are also part of what produce cultural messages. We see all the crazy messages coming from Silicon Valley to the world. If we don't balance that also in the other direction, they're gonna become owners of the cultural message associated with technology, the singularity and these kind of crazy things. You can agree with that or not, but the thing is, they don't have to be the only owners of the connection between culture and technology. We are working in some projects that they are not exactly data streams, but they come faster than usual, the data points. So you have to create strategies for pre-processes that are fast and that have some delay. Now, we are also starting to explore ideas and doing some experiments in things that are real streams of data. They are not huge data, but they nonetheless pose a lot of challenges because of the speed and especially because of the computational process you want to do. Even if the data itself is kind of small, you want to get a lot of information out of this. So we are doing experiments with video and face tracking. So we have some neural networks doing the work of analyzing this is already working because there is not done by us. There are fantastic frameworks for doing that, but this produces some geometrical data, vectors, that we want to use in real time for many purposes. It's for the time being experimental, but we can use this in different ways. For instance, for creating haptic interfaces. So it's your expression that controls your navigation throughout a landscape of data, for instance, or is the movement of your head. So it signals directions if you want to move, etc. There is this visualization device that is very controversial. It's called the Chernoff faces. You can use faces to associate different dimensions to different aspects of a face. right? Position, sizes, and even shapes, and even color. This is one of the ways you can try to do a multi-dimensional visualization, attaching multiple. It's very controversial, no one really knows it, maybe in certain situations. But the interesting thing about face tracking is that you are doing the same thing but in the opposite direction. Now you have the faces and you want to attach it to data. So indeed, we believe that in the future we're going to have more and more of these kind of challenges, and they are super interesting.